All right, this video is going to focus more on theoretical probability, what some people call simple probability. But let's get into it, and you'll have homework on this section, okay? And then tomorrow you will be doing, for e-learning, you will have a video on an experimental probability. And the only thing I ask you to do is just to take notes tomorrow. You get the notes today, and Wednesday when you come in, I need to see your homework from tonight, which is on theoretical probability, and also just the notes that I'm asking you to take on Tuesday, okay? All right, let's take a look at one. Look, is Khadijah equally likely? All right, well, we're not going to start off with one because we don't know from the other bag. So we're going to skip one. I don't want to talk about that one. All right, so I'm going to this look ahead part, and we're going to talk about theoretical probability. All right, when you find the probability of an event based on results from an experiment, it's experimental probability, guys. So probability based on results from an experiment is called experimental probability. And we will really get into that. That's going to be the video for tomorrow. But we want to focus on today theoretical, so I'm going to keep reading. All right, the theoretical probability, however, of an event is found by analyzing the possible outcomes rather than conducting an experiment. So they're very different from each other. The theoretical probability, I need everybody to put this little note for me. The theoretical probability is what we expect to happen in theory. But just because something is supposed to happen or work in theory doesn't mean it actually turns out like that when you actually conduct the experiment. Basically, it's not what happens in real life all the time. But now, the more trials you conduct in an experimental probability, the closer it's supposed to get to the theoretical probability. But anyway, I'm sidetracked. All right, let's go on. All right, so we're going to consider the spinners below. All right, the sections on spinner 1 are all the same size, as you can tell. They're the same size pieces on spinner 1. Section B and C on spinner 2 are the same size. These are the only two that are the same. And A is much bigger on spinner 2. All right, all sections on spinner 3 are the same, but you got an extra C, okay? So let's look at A. A says the sample space for an experiment is the set of all possible unique outcomes. For all the spinners, the sample space is the same. Okay, what is the sample space? Well, the sample space is just what are the outcomes you get. Well, you can get an A, a B, and a C, or a C from that. So that's your sample space on all three of them. They don't have a D or E or F on them. They just got an A, B, or C. All right, B, sometimes all of the outcomes of an experiment are equally likely. Other times, all experiments are not equally likely. All right, so let's take a look. We're going to explain why the outcomes for spinner 1 are equally likely, but the outcomes for spinner 2 are not. So what's the difference between spinner 1 and spinner 2? Well, spinner 1, it says all the outcomes are equally likely. That's because all the letter spaces are the same size. Okay? All the sections are the same size. But then on spinner 2, the outcomes are not equally likely. Why? Because section A is much bigger than section B or section C. So spinner 1 All outcomes are equally likely. Because all the sections are the same size. When I say sections, I'm talking about section A, section B, and section C. But for spanner 2, landing on the A is more likely because it has a larger section. It has a larger section than B or C. So if it's larger than B or C, it's not equally likely, guys. One's more likely than the other one. A is more likely than the other two. All right, C, when outcomes are equally likely, you can find the theoretical probability of the event using the fraction. So that's what we're going to focus on today. If the outcomes are equally likely, we're going to find the theoretical probability of this fraction. So the number of favorable outcomes over the total number of outcomes. And it goes on to ask, what is the probability of spinning an A on spinner 1? Well, spinner 1, because they're equally likely, I can look at that. I can actually calculate what's supposed to happen. Supposedly, which is theoretical probability, it's only one A out of 3 letters. Okay, so the number of ways the favorable outcomes, one favorable outcome out of how many total? Well, it's a total of 3. So that probability is 1/3 or 33%. D, for spanner 3, the outcomes are not equally likely. No, they're not. Because, all of them are the same size, but it's probably more likely you're going to get a C because you got 2 of them. The rest of them, you just have 1. All right, so to find the probability of spinning on a C, consider what fraction on the spinner consists of favorable outcome C. So, what are the ways I could get a C on spinner 3? What? Either these two ways. Out of how many? 1, 2, 3, 4. So, what fraction would represent that? 2 out of 4 or 1/2. Because 2/4 simplifies to 1/2. It's 2 ways to get a C, 4 total outcomes. All right, what's the probability of spinning a C on spinner 3? Okay, I already answered the question. Okay, I just kind of went ahead of myself. All right, 3, which spinner in problem 2 is most likely to land on a B? Which spinner has the biggest section for B? That's what I'm looking at. Well, if you look on spinner 1, section B is much bigger than the section B here or the section B there. So I'm going with spinner 1, because section B is larger. I'm going to put versus the section B on spinners 2 and 3. All right, guys. That's it for 710. Let's go to something like page 716 with the bagels on it, okay? All right, so we're going to use what we learned about theoretical probability and see if we can figure this out. Remember, theoretical probability is the ways that you can get something. They call it the favorable outcomes. All over the total outcomes, guys. That's theoretical. What should happen? What do we expect to happen? All right, 6. A board game uses a spinner at the right. As you can see, it's got the numbers 1 through 10 on it. All the spinner, all sections of the spinner are the same size. In order to draw a bonus card, so I guess they're playing a game, but in order to draw the bonus card, a player has to spin a prime number. So find the probability that a player would spin a prime number. Well, I told you all 1 is neither prime nor composite. Because in order for it to be prime or composite, it has to be greater than 1. So I'm only looking at 2 through 10. 2, the only way to get 2 is 1 times 2, so it's prime. The only way to get 3 is 1 times 3, it's prime. 4 is not prime. You can do 1 times 4, 4 times, or 2 times 2. 5 is prime. The only way to get it is 1 times 5. 6 is not. 7, the only way to get 7 is 1 times 7, so it is. 8 is not. 9 is not, because you can multiply 1 times 9 and 3 times 3. And 10 is not, because you can multiply 1 times 10 or 2 times 5. So the only prime numbers I have, my outcomes for prime, would be 2, 3, 5, and 7. So that's going to be 4 ways to get a prime number out of 10. And if you skip count by 2, because if you have problems simplifying, we have to skip count twice to get to a 4 and 5 times to get to a 10. So this will simplify to 2 over 5, okay? Let's take a look at 7. A teacher brings in bagels for her students. I think y'all be mad at me if I brought you a bagel. You might not want that. Maybe donuts. All right, there are 4 everything bagels. They look good though. 6 sesame seed bagels and 8 whole wheat bagels in the bag. So I know I need a total because the total always has to go in my denominator when I'm doing probability. 4 plus 6 is 10 and 10 plus 8 is 18. So it's 18 bagels. What is the probability that the bagel is whole wheat? Ooh, y'all would be so mad with me if I brought you a whole wheat bagel. It's like bread in the lunchroom. All right, 8 is 8 whole wheat. That's the number of favorable ways to get it out of 18 total. But you don't see that on A, B, C, or D. You don't see that as a choice. That's because you got to simplify. So I'm going to skip count by 2. I can get to 8 and 18. So to get to the 8 would be 4 times. And to get to the 18 would be 9 times. So this will simplify to 4 ninths. Magdalena. Interesting name. Magdalena records the eye color of everyone on her soccer team. So 4 people have blue eyes, 1 has green, and then 15 have brown. That's 20 people on the team. 15 plus 1 is 16. 16 plus 4 is 20. 20 people total on the team. What is the probability that a randomly selected person on her soccer team has blue eyes? Well, it's only 4 of them have blue eyes. I'm going to do this. Probability of blue eyes equals this. 4 out of 20. I need to try to simplify that. If you skip count by 4, 4, 8, 12, 16, 20. 1 time to get to the 4 and 5 times to get to the 20. That's 1/5. What about the probability of green eyes? Well, how many people have green eyes? Only 1 out of 20. So that's 1/20th. Guys, and I'm going to tell you something. You can change these things to percentages. If you take your calculator and do 1 divided by 5, and just move it, you're going to get 0.2. So that's as a decimal. But then as a percent, you got to move it 2 places to the right. So that would be 20%. So it's 1/5 as a fraction, 0.2 as a decimal, or you could do top and bottom out. You could T-bow this to get the 0.2. And it's 20% as a percent. All right, let me do this. If you T-bow this, or you take your calculator and do 1 divided by 20, you're going to get 0.05 as a decimal. So what I'm doing is expressing my answers as fractions, decimals, and percents. So as a fraction, it's 1 out of 20. As a decimal, the probability is 0.05. And as a percent, slide your decimal 2 places to the right. That will be 5%. All right, but then you also have to do brown eyes. Whew. Okay, let's get to brown eyes. Probability of brown eyes. I'm going to use P for probability. Well, that was 15 people had brown eyes out of 20 total. I am going to simplify this by counting by 5s. 5, 10, 15, and 20. That's 3 out of 4 in simplest form. If you T-bow that, that's a fraction. But if you T-bow that fraction or do top and bottom out, it gives you 0.75. So that's the answer as a decimal. But in percent form, it is 75%. So I just expressed all of them as fractions. You can express probability 3 ways using numbers: fractions, decimals, or percents. I did all 3. But more than likely, you'll see fractions. But I would just be prepared. You might be able to see, you might see any of them. You might see decimals. You might see percentages. I don't know. So I'm just trying to show you all of them. All right, let's take a look at this. All right, so we already talked about the probability of an event. And simple probability, guys, is just the same thing as theoretical probability. This is the last page. Like, what do we expect to happen? All right, the ratio of the number of favorable outcomes compared to the total. Favorable outcomes compared to the total number of outcomes. In other words, a measure of how likely it is for something to occur. Okay, and again, it's what we expect to happen. So we're going to do this the same way that we did the bagel problem or what have you. All right, let's look at a few examples. If a typical die, which is a standard die, is rolled, and its numbers 1 through 6 only, what's the probability of rolling a 4? Well, how many 4s on a die? If these are the only numbers you have on a die, then you only have 1 4. So that's 1 4 out of 6 total. 1/6. Now you could express that as a decimal by punching in the calculator top divided by bottom 1 divided by 6. You just get this repeating decimal, but I'm not going to write that one as a decimal, okay? All right, a prime number. So 2 is prime, 3 is prime, and 5 is prime. So that's 3 out of 6 as a fraction, which will simplify to 1/2. As a decimal is 0.5. 1/2 is 0.5. And as a percent, it is 50%, guys. All right, a multiple of 3. Well, 3 is a multiple of 3, and so is 6. So that's going to be 2 out of 6. If I skip count by 2, 1 time to get to a 2, and 3 times to get to a 6. So this is also equivalent to 1/3, guys. All right, let's take a look at another example. A bag has 8 red marbles, 5 yellow marbles, and 2 white marbles in it. So it's 15 marbles. 8 plus 5 is 13. 8 plus 5 plus 2 is 15 total, okay? All right, you reach in and grab one marble without looking. You put the marble back before drawing another one. Okay, what's the probability of drawing a white marble? Well, it's 2 of them that are white out of 15. Let me see what this is as a decimal of 5. I'll punch this in using my calculator. I just don't want to do some repeating decimal, guys. Which I think that's going to repeat. 2 divided by 15. Yeah, 0.133333. I don't want to deal with that one right now. All right, this is going to be 5 yellow. Probability of getting a yellow. 5 out of 15. And if you skip count by 5, it's going to be 1 out of 3. Well, in simplest form. Red or white? What do you do in those cases? Well, you just put them together. To put them together, you just count them all as 1. Count all as 1. Okay, so we got 8 red and 5 yellow. It's going to be 13 out of 15, guys. And that is all you do. Simple, simple, simple. I think I did red and yellow. Oh, it's supposed to be red and white. I'm sleepy, guys. I'm off. I'm off right now. Let's fix this. I know some of y'all probably looked and said, Miss Blue, you circled the wrong ones. Okay, I caught it. All right, 8 and 2, that would be 10 out of 15. And if I skip count by 5, that's 2 and 3. So this also simplified to 2/3. Red and white. Make sure I got it right this time. That's so much better. All right, guys, that is it. I just need you to do your homework, okay? All right, thank you.